Good afternoon, ladies and gentlemen, and a warm welcome to our Yara webinar, Wondering How to Improve Nitrogen Use Efficiency. My name is Eva Ross, Marketing and PR Manager for Yara UK and Ireland, and I'm joined this afternoon by my colleagues Mark Tucker, Head of Agronomy and Business Development, and Natalie Wood, our Country Arable Agronomist. So our area of discussion today is how to improve nitrogen use efficiency. So what is nitrogen use efficiency? Well, in a nutshell, it's the relationship between the total nitrogen input compared to the nitrogen output. And there are a number of areas that can help improve nitrogen use efficiency, which Mark and Natalie are going to take us through over the next 40 minutes or so. Natalie will cover how much nitrogen to apply for second applications and how can Yara tools improve your nitrogen use efficiency. She'll also cover nitrogen on spring cereals, followed then by Mark, who will guide us through tissue testing, the why and when, and which micronutrients are important at T1 timing. So Natalie, at this point, I'd like to hand over to you. Natalie.
Thanks, Eva. So yeah, let's head straight into it. So there's been a lot of activity in the past week or so with spreaders out across the country. If you've not applied your first dressing yet, then be aware that the crop only builds that biomass in the form of tillers until around the 3rd week of March. So getting the nitrogen on before that switch is key to manipulating that tiller production and effectively getting to that target, which is that 1,000 shoots per metre squared in April. And as I mentioned, once you get to that 3rd week in March, it switches from that biomass phase through to the reproductive phase. So it means that there's no more tiller production or the ability to manipulate it then. So when we're thinking about those second nitrogen applications, then it's likely to be around 50% of your total nitrogen. And we want to use a nitrogen plus sulfur product at this timing as well. And there's a couple of reasons for that. So nitrogen uptake and utilization is going to be improved when there's sufficient sulfur present. And that's obviously going to help increase the nitrogen use efficiency. And secondly, sulfur work shows that applying little and often is more effective and beneficial for the yield compared to applying it in one go. So those are just a couple of reasons as to why we're going with an NS product for this second application. So in terms of the rate of nitrogen, how much should you apply? Then, as I've mentioned, we know it's going to be roughly about 50%, but can we get smarter about this and subsequent nitrogen applications? And luckily, the answer is yes. It's about using the right practices and tools to link to nitrogen use efficiency. So there are 3 components to nitrogen use efficiency. If we look at the first one, then it's about uptake efficiency through the root. So calculating the total above ground biomass nitrogen values compared to the nitrogen that's been available to the crop. So as Eva mentioned, nitrogen in versus nitrogen out. Secondly, it's about how the plant utilizes that nitrogen it's taken up and converts it into grain, which then is obviously harvested. And Mark's going to cover this in a bit more detail in terms of how you can increase the plant's ability to utilize that nitrogen effectively and efficiently with other nutrients. And then the third part is the harvest index, which looks at the nitrogen in the grain compared to the total uptake. And Mark's going to mention a little bit on the remobilization, but we will probably cover that in another webinar closer to the time, but it's basically about getting the information you can from that grain. So how can we influence nitrogen use efficiency? So unfortunately, there's lots of different things that do affect nitrogen use efficiency. There's just some there. So we've got the soil conditions, temperature, aeration, organic matter, etc. Weather conditions as well, which of course we can't really control. And also nutrient deficiencies, and we've also got pests and diseases in there. So lots of different factors can influence the nitrogen use efficiency. So with all the ones that we can't control, what can we control? So really it's looking for the right product with the right timing, the right rate, and then the right tools. So therefore, good agricultural practice gives us a good starting point, making sure we've got the basics correct, such as the pH, having nice aerated soils, good levels of microbial activity, and things like that. But also it's about choosing the right product for the job at the right time. So just as an example, if we think of elemental sulfur, then just being aware that there's a delay in it being accessible to the crop whilst it goes through that conversion phase into the plant available sulfate. So it's just knowing things like that and taking that into account, because what we don't want to do is impact upon that crop's growth. For example, if you weren't aware that there was a conversion, then you could be delaying that growth, particularly with that first nitrogen application, because we know that the sulfur helps the nitrogen be taken up and utilised. So what we don't want to do is delay the crop at these vital early growth stages. So when we've done all we can in terms of the good agricultural practice, then the next step is really to use the tools that we have available. And that's where you can really start to see some bigger gains in the nitrogen use efficiency and get up to those 80% kind of values. So if we start with the most basic kind of tool that Yara can supply, we start with the IRIX app. Now there's a little bit of confusion because the IRIX app will soon change its name and it will become the @Farm app. So just be aware of that. It still is in the App Store and Google Play at the moment, but yeah, just be aware that it will be changing across to @Farm. So in terms of what it does at the moment, you've got the ability to show the crop uptake of nitrogen after the winter, and it can help you then decide on the amount of nitrogen for this first application. So if you've not applied yet, then this could still be useful to you. Let's just have a quick look through what it does. So it asks you for various parameters. You can also, with oilseed, do some measurements before winter, and it will take you through in terms of what parameters you need to put in there. And then the next step is it will tell you how much that crop needs, how much it's taken up, and then also fresh matter as well. And you can also use this for winter wheat. So you can see there, this crop had taken up 10 kilos. So it just gives you an idea really of what's in the crop and can help you decide on that first nitrogen application. So when we're thinking about our second applications, then that's when it starts to get a bit more complex. So what we're talking about now is the Yara N-Tester. And you can determine your second, third and fourth applications with the N-Tester if you want to. And that works on winter wheat, winter barley, rye, triticale, and then spring malting barley as well. And that's a little picture of the newer version of it there, which is the BT Bluetooth version. So how does it work? Effectively, as you can see in that picture, you will pinch a leaf between the gap that you can see there. And what it's doing is measuring the amount of chlorophyll that's in that leaf, because it looks how much light goes through that leaf and can determine the chlorophyll content. And that directly correlates to the amount of nitrogen that's also in that leaf. So basically, it can tell you the level of nitrogen that's in that leaf that you've tested. Not clicking, there we go. So within the IRIX app again, the functionality of the N-Tester is within there. So again, you'll be putting some various parameters in, such as the variety, whether it's milling or feed, and then the growth stage. So you can see there's the second, third, and potentially fourth protein dressing growth stages in there. So once you've put all your parameters in, it will then ask you to which N-Tester you want. You can use, or you should be using, the IRIX app in conjunction with the older N-Tester too. And the reason for that is the software will no longer be updated for that older version. So if you want to get some of the latest varieties, you need to use the IRIX app in conjunction with that 3-digit value that you'll get from your older N-Tester, and it will give you the recommendation for the newer varieties. So once you've done your 30 readings, you'll get your nitrogen recommendation there, and you can see all the values if you want in terms of the 30 readings you've taken, and then it also shows you what crop you chose, the variety, etc. So a very useful tool in terms of trying to see what nitrogen is in the crop. And in terms of data, we've done quite a lot of trials on the N-Tester over the years, and this was a trial that we did back in 2017. Looking at nitrogen use efficiency with various different methods. So the first column there is what RB209 would have recommended. So you can see it's quite low there in terms of the percentage, and this is due to that yield factor. So I think we'd planned for a 10-ton crop in this instance, so we were able to put on some more nitrogen because of that extra 2 tons above the recommendation. You can see the N-opt of the trial was better there with the nitrogen use efficiency. And then if we look at a professional farmer segment, again, in terms of what they applied in that year, it's relatively low again in terms of the nitrogen use efficiency. And the 2 treatments that we're interested in are these 2 N-Tester regimes here. So this first N-Tester regime, we put a massive dose on of 120 at the first timing, and the reasoning for this was we really wanted to push that device and see what it threw back at us. So yeah, massive dose to start off with, and you can see the N-Tester only put on 30 kilos for the second and 30 kilos for the third application there. So it was trying to show you that you'd put on a lot in that first instance and then balancing it with smaller amounts in the second and third. But you can see there, because we put that massive dose on, we've got quite a low nitrogen use efficiency. For the second regime, we've put 40 kilos on to start with, and then you can see that the N-Testers wanted to put 55 and 35. So you can see that massive leap up to 74% in terms of nitrogen use efficiency there. And then the average for those 2 treatments was coming out at around 56 there. If we look at the improved margin over nitrogen fertilizer costs, then we get some slightly different results. So as you'd imagine, the RB209 one was still coming out at relatively low. The N-opt was improved, and the professional farmer segment again was relatively low. But what's interesting here is that first N-Tester regime, excuse me, whilst it might not have been a very big increase in the nitrogen use efficiency, you are getting a lot higher margin back through the decreased use of nitrogen in that second and third application. And again, as expected, the 74% nitrogen use efficiency treatment, which was the second N-Tester regime, is giving us the best margin there at 652 pounds per hectare. And again, you can see the average between those 2 N-Tester treatments at 625. We did a trial again in 2019. This was an N-dose response trial, typical curve that you'd expect to see. And the N-opt of that trial was coming out at 223, which is that red dot there. So we had an N-Tester treatment again, where we applied 100 kilos at that first dressing and then used the N-Tester to recommend the second and third applications. And you can see the N-Tester applied 60 kilos for the second and then 40 kilos for that third, which totaled 200, which is that purple dot. So again, if we compare that to the RB209, which had the yield adjustment, so we had an extra 80 kilos for that yield adjustment, that was coming out at 46% efficient. The N-opt was 53, and then the N-Tester was 57. So we got an 11% nitrogen use efficiency increase from using the N-Tester. So in terms of variable nitrogen applications, why would we be interested in doing these? Well, if we look at a field, you can see we've already seen that nitrogen dose response curve on the previous slide. Across a field, you're going to get a lot of different response curves depending on the area that you are within the field, through the various variation in soil, etc. So what we're doing when we're applying variably, of course, is only applying nitrogen to the areas or the crops that the areas within the crop that require it. So we're boosting the growth in those poorer areas, which means we're increasing the yield there, but we're also decreasing the amount of nitrogen on the lush areas. So we're spending less on fertilizer. And of course, with less over application, you've got less lodging as well. And so what we're aiming for is this left-hand picture of a more even, homogeneous crop, which is obviously going to be easier to harvest as well. And as well, you can expect, on average, about a 4% yield increase from variable applications of nitrogen. Of course, there is also the N-sensor, which has again been around for quite a long time. How does the N-sensor work? Then basically it's measuring that reflectance value of 2 different wavelengths, infrared and visible, and it uses then different algorithms depending on the crop to turn that information into a nitrogen recommendation. And obviously, because it's on the tractor, you're going through the field, it's working in real time. So as you travel through that crop, it's putting on exactly what that crop's telling it needs. And so therefore, it's still the most accurate way to variably apply nitrogen. But of course, with all that technology, it does come at a cost. So potentially, a more affordable option might be @Farm. So what is @Farm? Basically, it's web-based software that uses satellite imagery teamed with that N-Sense algorithm that I was speaking about for a more accurate satellite-based nitrogen recommendation. You can upload existing maps, or you can add manually and draw the borders in yourself. But you can quickly create variable rate application maps, which will be compatible with most variable rate application spreaders out there. And just a very quick run through in terms of a screenshot. When you've mapped your field, this is what you'll see in terms of the variation. So you can see there, in terms of comparing it to NDVI, NDVI only has a range of, I think, about 9 colours, whereas our N-Sensor one, I think, has up to 27 different colours. So you can see the more accurate variation that you can get across the field. Once you've added in the fertilizer and what you want to use, it will create this map here. You can either have it in zones, or you can have this raster map here, which shows the more accurate 20 by 20 grid here for the biomass. And then once you've put your desired product in and the parameters, you will end up with this application map, which you can then export out as a shape file, which you can see there on the left-hand side in terms of the different brands. So it's as simple as that. So that's @Farm in a nutshell. So it's a more affordable way into perhaps starting out with some variable rate nitrogen applications. And at the moment, we do have an offer running, which is time limited. So you've got until next Monday before this offer runs out. And you will actually get the N-Tester Bluetooth plus @Farm together for just $295 for a year's subscription. So yeah, for that price, I would definitely recommend trying it, see how you get on. I don't think you'll be disappointed with either of those tools. So well worth the $295 there for the year. So when we go on to spring cereals, of course, when we're thinking about the nitrogen rates, then that's really denoted by that end market and the final grain nitrogen percentage that you're aiming for. Early drilled crops are able to handle higher nitrogen rates, but of course, if it's a later drilled crop, they're prone to higher grain nitrogen from later applications. So stick with those earlier nitrogen applications. And if we look at a trial here from 2019, we can see that the N-Opt of that trial was coming out at 161 kilos of N per hectare there on spring barley. From that same trial, then it showed as well that we get an increase for every 20 kilos of nitrogen that we increase, we get a 0.06% increase in the grain N content as well. So yeah, just be aware that the higher rates of nitrogen, you will increase that grain N content, but also the timing of that is obviously key. If we look at some timing trials, then this was on spring wheat in 2018, and we're looking at a couple of things here that I want to point out. So firstly, the applications after growth stage 30 both show a decrease in yield. So just showing really how important it is to get all your nitrogen on by that stem extension timing. If you're wanting to variably apply, then yes, of course, you need some biomass first, otherwise the variable application won't work. But yeah, no later than that growth stage 30. And the second point I wanted to make was the splitting itself of the nitrogen. So rather than applying it all in the seed bed, we always get a yield benefit from splitting it. And the ratio could be 50-50, 60-40, 70-30. It doesn't really matter. The main point is that the split is what's giving you that yield benefit. So yeah, a quick run through, that's it from me. I shall hand over now to Mark, who's going to cover some of the micronutrients and tissue testing.
Great, thank you, Natalie, and hoping that we're all coming across loud and clear. Really good rundown there from Natalie in terms of just getting that second and subsequent nitrogen applications on, and some good comments there on the spring cereals. As Natalie mentioned right at the outset there, nitrogen use efficiency isn't just one single component. It's got a number of attributes to it. So I'm just going to run through mainly the second one there, which is about the utilization efficiency of nitrogen. Because once we've got it into the plant from the application to the soil, whether it's a fertilizer application or any nitrogen that's in there from other sources, whether it's a cover crop that's left some behind, whether it's nitrogen residues from other manures gone on, then once it's into that crop, then we need the plant to be able to utilize it efficiently, which all adds into that nitrogen use efficiency calculation. The third one there, as Natalie said, is more related to the sort of harvest index, the nitrogen harvest index, when we're really thinking then about the efficiency of remobilizing up to the grain as harvest comes. So that's something to think about, but we'll touch on that in a later webinar and when we get more into that timing. So we're really going to think about the utilization part when it comes to the photosynthetic machinery of the plant and growth and development. So really we need to think about how we do maximize that photosynthetic process in our crops, and how we maximize the sink, which is really about all those florets that are being initiated now, in terms of how many of those survive, how many of those come into grain numbers, and then how many of those actually end up with grain fill. So yeah, key nutrients that are involved in photosynthesis, key ones that are involved in developing that large sink. And then also just another factor which we hear more and more about, but something that is worth considering, is the impact of nutrients on plant health. Because obviously if you've again got disease incidents coming into the crop, then it's causing that plant to respire in a bigger way. So it's sort of energy going away from growth and development into just managing that disease itself. So just a comment there in terms of what's out there in the literature. If we think about that photosynthetic process, then quite a busy screen there in front of you, but really the process is nicely defined along the bottom where we've got that carbon dioxide coming into the plant. We'll come and comment on that in just a moment. Combining it with the water, turning it through to our simple sugars, so glucose, and that's really the really critical part. Is once you've got to that glucose process, then what happens after that to go into producing amino acids and proteins. But that first bit of photosynthesis is the water splitting, and immediately you can start to see how key nutrients that may be micro, but really have a very important role to play, because unless that water splitting process happens, then again photosynthesis stops. So two ones to really note there are that manganese and zinc, both required for that very first process. So manganese and zinc, really important to maintain efficient photosynthesis. As that process then develops, we know that the light energy coming in is very much trapped in the plant chemically through the ATP molecule, and that's, again, as you can see in the name there, there's P involved, so phosphate, very important when it comes to the energy store of the plant. And then that process happens through various protein complexes which contain copper, iron and sulfur. So again, three nutrients there that immediately mentioned that we're all becoming familiar with. Sulfur we know is deficient, so we need to make sure we've got an adequate supply of sulfur. Iron is very rarely a problem for us, but again, it's a critical nutrient. And then copper, something perhaps more familiar, where we see deficiency on a more regular basis. So again, more nutrients mentioned there in terms of making sure this process continues smoothly. And then obviously a lot of that, or all of it, is happening in the chlorophyll. And as you can see top right, then the chlorophyll molecule dominated by magnesium and nitrogen. And 75% of that chlorophyll is in the form of chlorophyll A, and that's what really, as Natalie's pointed out, we're using the N-Tester to help manage our nitrogen. And why can we do that then? Because chlorophyll A is a very nitrogen dense in the plant, so we can use that relationship to help manage nitrogen. So 75% is chlorophyll A, and that's what we measure with the N-Tester. Those chloroplasts that contain the chlorophyll themselves contain lots of sulfur-based proteins, so again, sulfur featuring, and as well as all of the organelles in the cells where this is all happening, they all have membranes around, and where we see membranes, then we know that calcium and phosphorus are important, not only for the integrity of the membrane itself, specifically the calcium, but also then the phosphorus helps transport products across that membrane. So you can just see from that one slide how we've got some critical nutrients that are all going to be happening as that plant photosynthesizes through its lifetime. I mentioned there that carbon dioxide critical coming into the leaf, and we can also then pick up on another key nutrient, this time one of the macronutrients in terms of its role to play there. And for that carbon dioxide to successfully come in to the plant through the leaf, and also for water, for oxygen to go out, because oxygen itself, if it builds up in the plant, will limit its photosynthetic capacity and act as a brake. So we want to really, again, have a plant that can manage its stomatal opening and closing to regulate and really perform well in terms of photosynthesis. And the key nutrient there, potassium, as you can see, is shunted into those cells around the stoma, and by doing that you create the osmotic potential, which means water will go in, the cell opens, and you then have a nice process of carbon dioxide coming in and out of that leaf to keep photosynthesis going. If that closes, then the plant obviously has to get its carbon from somewhere, so that starts to mine itself for that carbon, which is clearly what we don't want to happen, because that's very inefficient. So again, potassium, we've mentioned that on numerous occasions, but really important as a nutrient to get in there at this time of the year to make sure that crop can really function efficiently. The next bit then that we need to think about, and it's something that a molecule which is seen as the bridge between life and lifeless, as it's described, and that's the enzyme rubisco. And really that carbon dioxide with its carbon needs to be converted into that sugar, and the process there, which is really critical, is the rubisco enzyme in terms of how that's working. And it is the single most common protein on Earth, and for it to function correctly it needs magnesium and manganese. So again, a really critical stage where carbon dioxide is converted into sugars. That sugar then is what effectively leaves one cycle and joins the next cycle, where proteins, or the nitrogen that's been applied and taken up, is then converted and combined with that carbon source of the sugars into the amino acids and proteins, which all part of growth, development and yield of that grain. So that whole cycle, really critical. So we need photosynthesis to produce that sugar. That sugar then goes into then really processing and metabolizing the amino acids and proteins, which will come towards yield. So again, another two nutrients there, magnesium and manganese, mentioned in that critical process that we see. If we then think, that's really about the functioning of the plant and keeping it efficient throughout this next weeks, which is going to help us. So we can really think about that in terms of, are you seeing any of those nutrients that are deficient, or have you experienced deficiency? Then you need to address that to make sure they're not the ones that are limiting the nitrogen metabolism in that plant. What we also see is some of those key nutrients that help develop the large sink that we want to develop, that sink being the grain sites that we want to end up as grains, and then that grain fill period that happens. And there we've got nitrogen and potassium, very critical macronutrients, and we've shown this before to you too, just a reminder of work done that shows how making sure we've got sufficiency of potassium has a direct impact on the grain numbers per ear. So again, can't emphasize the importance of that nutrient enough, as well as the nitrogen that either has gone on now or is just going on in terms of its impact on final grain number. But also then we've got the micronutrients, and I certainly don't expect you to read all of those graphs, but they are all up on our website. So if you either Google or go onto the website, you'll see where this data is cited, and it all highlights the micronutrients there of manganese, copper and zinc, all showing anywhere from a 5 to 20% increase in the grains per ear. So again, if we want to build and develop that sink that we're wanting our photosynthesis effectively to then fill, then some critical nutrients again mentioned there towards that. So yeah, think about that in terms of whether any of those in your system are deficient. I mentioned earlier on that we don't want that plant to be of poor health. You obviously use fungicides to really maintain the health of the crop, and there's a great reason as to why that is. Clearly it's about protecting it from attack. What we also know, and I thank my previous colleague, but now many of you will know Ian Matz, who pulled together this work for us some years ago, where we looked at the literature to see how much literature is out there in terms of relating nutrients to disease, and whether there's an increase or decrease in incidence of the disease in various publications and research papers. And you can see they're listed there that some nutrients stand out in terms of their impact, either increasing or decreasing. But I think what's really important is it shows how we need to keep nutrients and crop nutrition in balance where we can. An excess of any one can have a negative impact. We can see at the top there, if we've got too much nitrogen floating around, then we have an increase in disease incidence. Whereas, likewise with other nutrients down there in the list, if we end up with too much, then we can encourage disease. If we get it right and we get the right balance in there, we can have a big impact on improving that plant's health, and therefore decreasing the incidence of disease. And three to note, potassium. Many of you probably wouldn't recognise that, but potassium, in terms of the integrity of the plant and its ability to help decrease disease, important highlight there. Calcium, one constantly talked about in many of the root vegetables, potatoes, also brassicas, then used for helping plant health and disease incidence. And again, calcium having a really important role to play. Manganese, copper, and boron at the bottom there. Maybe that's something you've not picked up before. Certainly came as a surprise to me when I saw this data in. But all those nutrients having a role to play in improving plant health. So really do think about that and build a balanced nutrition strategy so that we don't end up with too much sugar in the plant, because nitrogen's limiting, which can encourage problems, or we end up with not enough sugar, which leaves a surplus of nitrogen, which gives us issues. So we just got to really keep things in balance. So how do we think about keeping things in balance? Then it's really important that we do some analysis to understand and measure so that we can manage our nutrients. And we know that soil testing is great for that planning process to really understand and set about the strategy. We know at the end of the season we can use grain analysis to really understand how that nutrient has been remobilized, how it's now ended up in that grain, and is there an indication there that there's been some limitation through the year. So grain testing can be a valuable part of reviewing your strategy and seeing how you're performing. In the middle there is the leaf testing, and that's really the period we're going into now as we move through March, and I would say into April is always a great month when the plant is growing well, moisture availability, hopefully we haven't had severe drought, and we can really start to see and pick up any limitations that might be in there by way of a broad spectrum leaf analysis. So important to do that. Don't just go for those areas which are screaming at you in terms of problems. Go and pick some of the crops that are looking healthy, because underlying issues might be there which just aren't showing visible symptoms, that hidden hunger that Natalie's referred to a lot over previous webinars. So really do test good bits, bad bits, good representative areas of fields to see if there's anything that starts showing up for your farm and fields. And then you can send those samples off, and something which the Yara Analytical Services has moved on with is the critical values and interpretation of those results. So I've just got one example here, potassium, because it's something we've recognised over the years that just a standard one line critical value for the whole season really is and can be potentially misleading. So we've moved more and more to a system of understanding the critical value as time moves on through the crop's life, so that you can see the key stages there, T0 through to T3, and you can see how there's that natural decline, and this is pretty common with most nutrients that you have that decline. But what we also see is that the high yielding crops, and they're noted on that slide there, the numbers in the sort of brown boxes are all associated with high yielding crops. And what we know is that those high yielding crops do have a good level of nutrient in them, in terms of they've had sufficiency right the way through, so they're not acting as a brake on any of the processes in the plant. So again, another part of tissue testing and getting good results is the interpretation from that result that you've got. So that's something to note and think about where you send that sample off to in terms of the analysis and the interpretation that you'll get back. It's up at the land crop or Yara Analytical, then up at Pocklington, then you've got that growth stage approach now for your wheat, winter wheat, the barley, the oilseed, and then also we've got for the oilseed crop and petioles in potatoes. So there's very specific timings and critical values set there. We're working on the peas and beans one to get more data in for that. But yeah, so that's something to really think about, because you will get the interpretation back, which looks something like this. This is literally one that's come through in the last few days for oilseed, and you'll get that list of nutrients, the results for the field and the sample, and then the interpretation. I've blocked off here some of the detail, but on the right you would then get, if you've requested it, some interpretation of what those value means and some recommendations to think about going forward. You can classically see here this oilseed, which is why the product which is very pertinent at the moment is Brassicharb Pro. Well, this is an oilseed crop that's come back in the last few days, and it's absolutely typical of what we see, where we've got low magnesium, low calcium, boron, copper, manganese and molybdenum. Very classic for the oilseed crop, and Brassicharb Pro as a product going on at stem extension absolutely fits ideally for that sort of scenario. But yeah, look out for that sort of interpretation and think about which lab you send yours off in terms of what you get back by way of interpretation and guidelines. So how have micros performed over the years is all very well talking about the, what they do in the plant. Do they sort of come back and help us? Then, yeah, here's some examples of 2020 trials that we've done, whether it's the oilseed crop with our Brassicharb Pro, where we use that suite of micronutrients specific to that crop in 2020, giving us that 0.599 tonnes a hectare. Put that 0.59 tonnes a hectare in terms of money, and that's a serious amount to be missing out on. So really do, Brassicharb Pro timing is now to get that out and on. So 0.59 tonnes a hectare there. And then you look down and you can see on the right the wheat ones that we did, whether it was zinc, copper, or the boron application, which we've been working on for a number of years to get that right. We still think it's right to be splitting that recommendation out, half now and then half later, but all of those giving anywhere from 0.4 to 0.59 tonnes a hectare in terms of response. So if you do pick up deficiencies, then we know that putting those Yara Vita products on will then get that crop back to where it should be and deliver an extra yield for you. And of course, all of this extra yield is coming on the same level of nitrogen, so automatically improving the nitrogen use efficiency position. And then finally, as we see there in terms of Gramitrel, a classic product that we've been using for many years now with great success. You can see the rolling average there at 0.41 tonnes a hectare with our 2 litre per hectare T1 timing. So again, micronutrients play that critical role and just add extra yield on the same amount of nitrogen that you're applying, so automatically increasing and improving nitrogen use efficiency. I think there's some lessons that we can learn from and some take-home messages that I've highlighted there, but also come through when we look at the world record crop that was achieved. And yes, of course, we all aspire to those 17-tonne crops, but I think it's really interesting to see how they drove that yield through the use of the key sort of nutrient programs that they used. You can see Gramitrel was very much a feature of that program, but also the boron that we've also talked about. And then I think fundamentally you can see how they kept the percent nitrogen up in that crop using the N-Tester to help meet and manage the nitrogen applications going into it, to hold that nitrogen right through its growth. Yes, using a multiple application approach, which will help to achieve the high nitrogen in the crop going through the season. And then finally, as we've mentioned, potassium being really fundamental. Then they put a nice application of potassium in the spring to really, again, help drive that crop growth and development through the critical period. So some really good lessons that come out of that, even though we might not all achieve that 17-tonne crop. So to summarise then, the really key message is the last half an hour or so, then use the technology that's out there. As Natalie mentioned, the AppFarm, the N-Tester BT, to get that nitrogen rate accurate so that we improve our NUE there. Use all the data that's out there and drive for sufficiency of those key nutrients. Don't just think about deficiency, but think about sufficiency to really improve efficiency within the plant. Micronutrients do play that key role, mentioned right the way through: photosynthesis, amino acids, proteins, all what are going to deliver that final yield. And that key timing is the spring, early spring, really T0, T1. That's when we really want to be thinking about the key micronutrients. Boron is slightly the exception, where we come in with a later application. With the others, the manganese, the copper, the zinc, early is really the key timing, and stem extension in that oilseed crop. So hopefully that gives you a good rundown, something to really get you thinking. And I'm going to hand back to Eva to take us through the Q&A.
Great, thanks, Mark, and many thanks, Natalie, as well. And yeah, I guess, Mark, if we do all the things that are under our control, as Natalie mentioned there earlier, yeah, we can achieve a nitrogen use efficiency of 80%. And am I right in thinking, is it 60% is the average nitrogen use efficiency at the moment?
Yeah, I mean, it's probably not even as high.
Farms.
Yeah, probably not even as high as 60%. Actually, it's probably nearer the 40 to 50% for many. But we know that when we do the calculations on arable farms, that we can be up at 80%, and that should be our target, really.
So use the right product at the right timing, at the right rate, and with the right tools, and make sure to tissue test then as well. The good areas as well as the bad bits. Look out for that hidden hunger. Great. Well, thanks, Mark and Natalie. Yeah, we've had a number of questions, as I mentioned earlier, that came in with the registration. So we'll get stuck into those at the moment. I leave the basis code up there on the screen, so you can jot it down there while we're going through the Q&A session. Mark, I'll ask you to answer this first question. It's on winter linseed. What is the right time to start applying nitrogen and sulfur to winter linseed, and how many kilograms should be applied in the first application?
Yeah, I think with winter linseed, then looking at a sort of split approach where getting up towards a total of around 120 kilograms of nitrogen, going on with a first application to drive sort of early growth. If crops are behind, then go slightly higher, but 50 to 70 sort of kilograms then as your first dressing, and then balance that off a few weeks later in terms of the total getting up towards 120. Yes, again, it's an oilseed crop, so it responds well to sulfur, really looking at around 30 kilograms of sulfur into the system there with the nitrogen to maximize that sort of early development.
Great, thanks, Mark. And I'm going to stay with you, Mark. I've got a question here on boron deficiency. Boron deficiency regularly occurs in our cereals. Would it be best to take a little and often approach at T1, T2, as opposed to a single dose at T2 timing? What rates do you suggest are appropriate?
Yeah, the laboratory tells us every year that 80% probably of crops, particularly wheat, are showing deficiency in terms of boron. So it is a key nutrient, and it is a very important nutrient when you've got lots of cell division happening, and then for pollen viability and grain cell late on. So we've been doing work for a number of years now, and we've got further trials in this year to try and see if we can really home in on the timing. But what's coming through so far is that it does play a key role now and a key role sort of late on. And that's why I think we're seeing the best results in terms of yield responses to where we split that boron with the first application at T1, where we put half a litre a hectare in with our gramitrel, and then we come back at T2 timing with another half a litre. And with that, then, yeah, we're seeing the best return on investment performance-wise from that. So split the application of that boron.
Okay, Mark, and another question in here, which nutrients can be managed through foliar application? Mark, I'll ask that one to you, please.
Yeah, I mean, there's quite a bit of talk in terms of foliar nutrients and foliar nutrition, because it's perceived generally to be more efficient, and I think that would be the case, where as long as we've got leaf and enough leaf to hit and get that foliar product onto the leaf and in, so it can be very efficient. I think the two of or really we're thinking then which of those nutrients sort of have the high uptake requirement. And as we move through March and into April, then we've got crops taking up kilograms per hectare of nitrogen and potassium, and they therefore represent quite a challenge to manage those by way of foliar. What the other two nutrients, which are much lower concentrations in the plant and are relatively inefficiently taken up, are the likes of sulfur and phosphate. So they do represent opportunities, and of course the micronutrients where we can deal with foliar nutrition. So yeah, phosphate, that can go on now. We know that's taken up well and easily and efficiently, and we can have an impact on that plant. So there are foliar nutrients and foliar applications we can do. I think they become more relevant as we get through the sort of bulk canopy development stage, and we're then looking for just really maintaining green area and green area duration. Then we can very much target maybe foliar nitrogen, foliar potassium to help do that later on in the season, and foliar phosphate, as we'll mention, perhaps going forward, all part of making a plant remobilize its stored carbohydrate and protein up to the grain. So Yeah, I think we just have to be careful in terms of the risk we might have if we try and do some of the macronutrients through foliar applications when there is a big demand. Potassium, 7 kilograms per hectare per day, nitrogen, 4 kilograms, 4.5 per hectare per day. So you need a good supply of nitrogen under that crop to be meeting that demand.
Great, thanks, Mark. Good comprehensive answer there. Natalie, I'm going over to you now for this question. It's on the N-Tester Bluetooth and second application. In your opinion, what sort of recommendation will the N-Tester Bluetooth give for the second application?
Okay, so yeah, that's really the beauty of using a tool like the N-Tester. It's taking all that guesswork out. So when you're using that tool in the field, it's not guessing what the crop's taken up, it's measuring exactly what the crop's taken up. So you're talking about real in-field data there. So the one thing I would say is trust the information it's giving you. I've heard people say before, well, I wanted to only put on 20 kilos, so I put on 40, and now I've got 14.5 protein percentage. So yeah, just go with what it's recommending you to do. That's the reason for having this tool, taking all that guesswork out. So trust what it's saying, really, is my answer.
And Natalie, just staying with you now for the next question, can you clarify the different apps available from Yara?
Yeah, sure. So yeah, sorry for the bit of confusion at the moment as we're in this kind of transition period. So currently IRIX is the app that I showed there, and it's the app for doing the photo analysis, and also if you want to use the N-Tester, and that's the old N-Tester as well as the new N-Tester. So yeah, if you do have an old version of the N-Tester, as I mentioned, you need to use the app to get the latest varietal data in there. The AppFarm app is also currently an app, so that's what you use in conjunction with the AppFarm software, web-based software. So you can see what your fields look like, look at the nitrogen maps, etc. through the AppFarm app. But very soon those two will actually be integrated into one app, and that will be AppFarm. So that's going to be kind of a one-stop shop for all the Yara systems, so you'll only have to go to the one place, which will make things easier. Within the AppFarm platform as well, so the web-based software, that's currently or constantly being developed. So we hope to have different functionality within there as time goes on. So integrated use of the N-Tester with the AppFarm mapping to make the variable application maps even more accurate, as well as things like crop nutrition plans, and hopefully as well the lab analysis will be integrated too into that. So yeah, at some point AppFarm will definitely be one to watch out for future updates, because it'll be your go-to place for anything to do with Yara.
Lovely, thanks, Natalie. And Mark, I have a question here on tank mixability. I'm applying UAN. Can I tank mix it with micronutrients?
Generally, the answer there is no, in the sense of what you're really wanting with if we're thinking about a seed bed application or a planting application, then there's some potential options there. But generally, we're now going into a period where we're putting that UAN through the crop, and we're wanting to target the soil with that UAN. So we're putting that down for application and therefore uptake from the roots, whereas the Vita products and the foliars, as we go through now, are going to be utilised through the leaf. So that's where we're putting them on with the sprayer. But what we're not asking you to do an extra pass or anything, because what the formulation of the Vita products is all thoroughly tested up at the labs. Any product that's available has been through a strict process of formulation, making sure that when the nutrient hits the leaf, it gets into the plant, it gets to the new leaf, and we have all that sort of documented by way of nutrient uptake, and it's then formulated with spreaders, wetters, humectants, etc., so that we optimize again the uptake. But what it also gives is tank mixability, so the formulation, so we know then that if you're putting it with fungicides, with other PGRs, etc., herbicides, then we've got very good tank mixability. And to to confirm the tank mixability, then there is the tank mix app out there, which has many tank mixes which you can check to make sure there's compatibility. If it isn't on there, then we have a 24-hour service where you can request a tank mix. What it gives you is a physical compatibility so that we don't end up with glue in the sprayer. So if you are coming up with some pretty high number of products going in for the tank mix, then you want that checked physically, then we do have that 24-hour service that operates out of Pocklington. Excellent service that, you know, we're always being complimented on, so do make use of it, because it's there for that reason, so that we don't cause any problems in the sprayer, or we want to manage or minimize the number of applications through the crop for you.
Great, thanks, Mark. And I'll just take two more questions. Mark, just staying with you now for the next one. It's a great question on grain and soil samples and tissue testing. I send grain and soil samples off for testing each year. Do I also need to tissue test?
Yeah, I think the answer really is there is no silver bullet, if you like, of analysis which is going to give you all the answers, and therefore you can then sort of carry on without doing anything. I think the whole point of analysis is about monitoring what's happening within the soil, within the crop, and the grain gives us a real reflection of what the season you've had and the strategy you've taken. So that can really give us a good, valuable input into reviewing and then determining strategies sort of for the following season. So it may confirm that things have gone well, so you carry on, or it may confirm that there's still some missing elements that you need to address. So I think the grain testing gives us that good sort of review reflection. What we then want to utilize the tissue testing for is very much tactical. Is something happening that's perhaps caught you unawares, either excessive rainfall that's suddenly depleted a nutrient, or you've introduced a different rotational aspect to your farming, or a manure or something which has changed the picture. Then if we're doing some routine tissue testing, then we're going to pick up those sort of tactical issues that happen in the season, in the field, which we can address with an immediate response to. So, and then the soil one is again all about sort of enabling us to do a good plan. So it's about planning, tactical management, and dynamic management in the season with foliar, and then finally reviewing tissue testing. Of course, if you start to get very common picture and things are going well, you don't have to be doing every field every season. You can sort of come in and do it rotationally to check how things are going and just monitor then progress.
Thanks, Mark. And Natalie, final question to you then on sulfur. Should we include sulfur in the second application?
Okay, so yes, definitely would be my answer. As I mentioned earlier, then nitrogen needs sulfur to be taken up and utilised with it. So yeah, for it to efficiently work within the plant, you need the both of them there. So therefore, ensuring you've got that adequate level of sulfur increases your nitrogen use efficiency. Sulfur also acts very similarly to nitrogen in the soil, so it means it readily leaches. So putting it all on in one go isn't really a good idea if you want to supply the crop throughout the full season. And I've said it before, you wouldn't apply all your nitrogen in one go, so don't do the same thing with sulfur.
Great, thanks, Natalie. Well, ladies and gentlemen, that concludes our webinar today. Many thanks to Mark and Natalie for their in-depth presentations and also the Q&A session. So many thanks, and yes, we hope to be back soon. Take care.